This video will show the procedure to check crankshaft deflection on G3600, 3600 diesel, and C280 engines. The crankshaft can be deflected or bent if the installation of the engine is not correct. If the engine mounting rails are not fastened correctly to the foundation mounting rails, the cylinder block can twist or bend and the crankshaft can deflect. This can affect crankshaft and/or bearing life. Crankshaft deflection must be checked cold after the final installation of the engine, and then hot after the engine has reached operating temperature. While taking off the cover to conduct the hot deflection check, lay the deflective gauge on the mounting feet to stabilize the temperature of the gauge. Let's review the procedure for engines that drive equipment from the rear. For a 6-cylinder engine, measure cylinder journal 3 between cheek 5 and 6, and between cheek 11 and 12 to check journal 6. For an 8-cylinder engine, measure cylinder journal 4 between cheek 7 and 8, and between cheek 15 and 16 for journal 8. For a 12-cylinder engine, measure journal 5 and 6 between cheeks 5 and 6. Measure journal 11 and 12 between 11 and 12. And for a 16-cylinder journal, measure between cheeks 7 and 8 for cylinder journals 7 and 8, and measure between 15 and 16 for journals 15 and 16. Deflection must also be checked at the connecting rod journals for engines that drive equipment from the front. For a 6-cylinder engine, cylinder journals 3 and 1 must be checked. Measure between cheek 5 and 6 for journal 3, and between cheek 1 and 2 for journal 1. For an 8-cylinder engine, it's journals 4 and 1. Measure between cheeks 7 and 8 for journal 4, and 1 and 2 for journal 1. For a 12-cylinder engine, measure between cheeks 5 and 6 for journals 5 and 6, and between cheeks 1 and 2 for journals 1 and 2. And for a 16-cylinder engine, cylinder journals 7 and 8 and 1 and 2 must be checked. Measure between cheeks 7 and 8 and 1 and 2. Now let's go over checking crankshaft deflection. First, remove the appropriate inspection cover from the cylinder block. Add a divot approximately 10 millimeters from the edge of the counterweight. Turn the crankshaft in the direction of normal rotation until the counterweight's center barely go beyond the connecting rod. For inline engines, install at 2B 7218 bolt with a 1B 4333 nut, or 2J 3507 full nut in the crankshaft. Tighten the nut against the crankshaft. The bolt and nut provide a locating face. Make sure to remove the bolt when done. At this point, note, if the connecting rod or rods hit the indicator, it will likely fall into the oil-filled pan. To allow easy retrieval of the tool, tie a string tether to it with the other end secured outside the block. Then install a Starrett crankshaft distortion dial gauge number 696 and a Starrett number 696B between the bolt and the counterweight. Align the zero with a pointer by turning the dial of the dial indicator. Turn the dial indicator on the endpoints until the pointer of the dial indicator will not move from zero. Put the dial indicator within 10 millimeters or 0.39 inch of the end of the counterweight. Some crankshafts may have center punch marks in the proper locations. Place a center punch mark within 10 millimeters or 0.39 inch of the edge of the counterweight for gauge placement. Now turn the crankshaft in the direction of the normal rotation until the dial indicator almost contacts the connecting rod, which is on the other side of the crankshaft. But make sure the dial indicator does not contact the connecting rod. Be sure to document the readings at 10, 8, 6, 4, and 2. The dial indicator reading must not change more than the appropriate value for the approximate 300 degrees of crankshaft rotation. For front and rear cylinders, this would be 0.18 millimeter or 0.007 inch. For middle cylinders, this would be 0.08 millimeter or 0.003 inch. Turn the crankshaft in the opposite direction to the starting point. The dial indicator must now read 0. If it does not, do the procedure again. If the dial indicator reads more than those maximum acceptable indicator readings, the cylinder block may be distorted, or driven equipment may not be properly aligned. If that's the case, you must check soft foot and alignment to see what is causing the deflection to be out of specification. Loosen the bolts that hold the engine mounting rails to the foundation mounting rails. Then adjust the shims in order to straighten the engine. There has to be enough clearance for the engine mounting bolts to allow the engine to expand when it gets hot.